Hi, my name is Joan Reister. I'm with AWS. I lead our mainframe modernization practice for financial services. I've been at AWS for about 2.5 years. And prior to that, I was at IBM for 20 plus years, also 10 of those doing mainframe modernization, both in sales and delivery. So today I'm going to talk to you about how customers are accelerating their mainframe modernization journey to cloud. So to start that conversation, in case there's people on the phone that don't have a good understanding of mainframes have been around for a very long time. So I have a friend in Japan who kind of ties it to Godzilla. So the first high-speed processing machine was developed in 1950s for, and so was the Godzilla movie. The majority of mainframe applications are 40 to 50 years old. They were developed in the 1980s at about the same time as Return to Godzilla. So, and as they grow, the speed of them grow and the ability to process grows. So in, 2013, you have Godzilla minus one, but, think of a mainframe as 32 AWS instances, running, at one time. So mainframes are around. They've been around for 40 to 50 years. I'd say used heavily in financial services. Pretty much every financial services customer over 50 years old has a mainframe or mid-range system. So why are customers moving off a platform that's stable? A lot of it has to do with high costs. So in the last 2 years, there's been, I'd say, a trend for software licensing companies to increase licensing costs like 3 to 8x. So because of that increase, customers, it's making it cost prohibitive. So on top of that, you also have, because these applications are 40 to 50 years old, you may have limited constraints as far as innovation and agility because it's not architected the way you want it, the data is not available to customers, or your resources that are managing the applications, or even the business teams who develop the applications for the business are retired. So that loss of knowledge, the ability to go fast, based on the tools on the mainframe, and those licensing costs are what's driving people to modernize today. So generative AI has played a big role in the last 18 months to accelerate that path. So based on people's business goals and objectives, their challenges and constraints, and their tech stack, it really drives the patterns people pick to modernize their applications. So because I'm going to use some of this terminology as we move forward in the presentation, I just want to explain it. So when you hear people want to make their data available, that's augmentation. So if you want to create new functionality, you want to do analytics, those would be things where you make the data available. Customers whose function works well for the business, they refactor. That means basically you take your application with the function it has today, it has the same function in cloud, but it's in a modern language. So it's easier for DevOps and your data is available. People who want to exit a data center quickly or have lots of, let's say, legacy resources to manage their applications, they might want to leave it in the current language it is and just move it to cloud. So again, they have quicker DevOps and they have availability of the data. And then some people rehost, which it may happen for a couple of reasons. One, I have not started my mainframe journey or modernization journey at all. All my apps are on-prem, and I want to start moving to the cloud, but I have latency constraints. So people may move their mainframe in close proximity to get rid of that latency issue. Or if there's no business case to move an app because it may follow one of these other two patterns of retain and retire, they may move those workloads to our rehosting location. I'd say the largest change in modernization, I'd say, if you asked me 5 years ago, I'd say refactor, replatform, and augmentation were the largest patterns because reimagining or rewriting took a long time, cost a lot, almost double. So reimagine in the last 18 months has really, I'd say, accelerated as a pattern for modernization, just because the tooling advancements make it much more, cost efficient to rewrite or redevelop products for companies. So generative AI has really helped accelerate this whole path, and it helps accelerate even other paths like augmentation, refactor, and replatform. But when I've talked about so far as the application, so I have this egg analogy. So think of your application and your data, which is what I was talking about before. That's a core, but it's like an egg yolk. Nobody wants to eat an egg yolk by itself. You want a whole egg. So there's all those other interfaces, like for example, you print statements for your customers, or you have a scheduler that runs for batch data that provides data to your front end applications for your customers. All those things have to be taken into account of when you're looking at your journey. And then testing. So testing is one of the biggest areas for I'd say acceleration, because testing is 40 to 60% of any modernization project. So testing is key. to, I'd say, shrinking the timeline and the cost, which gives you a better ROI, which gives you more likely to get funding for your project. So again, generative AI is accelerating different components of the process for modernization. But one of the core things too is nobody wants a raw egg. So you think of AWS as your frying pan. So that's where you have your end-to-end observability, your security, things for your resiliency and your environment setup and scalability of your environment. So that's the frying pan. So as you're looking at your modernization journey holistically, your application is key, but these other components have to be taken into consideration as you accelerate your journey. So generative AI as a whole has really, I'd say, grown the most in these three areas. Understanding is the most growth because understanding is really key to modernization, and I'll talk about why as we go forward. The testing, which I kind of alluded to on the previous slide, and your code transformation, being able to create new code for that capability you want to have, let's say, in the reimagined space. So how do I start? So first you have to understand what you have in use. And this goes towards understanding. So customers, when they modernize, it's generally the estimation is based on lines of code. So when you understand what you have in use, that can greatly reduce as you do this analysis. So we had, if you're a large, let's say a large insurer, we had one that had 119 million lines of code, which is almost an insurmountable amount. Like, how do I'm going to modernize something that large? Well, when they did an analysis of what they had in used, they dropped their code base over 77%. So now that's a much more reasonable, it's still a large amount, but it's still a much more reasonable size to do the modernization on. I had another CIO who had no mainframe experience, and he inherited a portfolio of applications. And again, he had no idea what they did. And even for him, like 7 million lines of code is a lot. So they did an analysis and they dropped their whole, volume of code of what they really used down to 28%. So as you can see, just understanding what you have and use really drives, a reduction in what's your overall cost and timeline would be to modernize since it's based on lines of code. So how do you determine what you have? So the static code analysis tools have been around for 20 years. Static code analysis tools will give you like the application dependencies, like program A calls program B calls program C, and here's the data elements it used. So pretty much these mature tools have also incorporated generative AI to even provide better insights into the code. But that only tells you what you have. It may tell you also dead code. So it'll tell you code paths that are never called into code, but it doesn't tell you what you use. And that's really where you get the code reduction. So incorporating dynamic analysis, which would be a job scheduler, or your workload data on the mainframe, which is called SMF data, and creating generative AI scripts, you can now help identify based on your workload, your dynamic data and your static data, what is really used. So customers typically see about a 30% average in code reduction. So again, 30% average in size. If the size is based on your lines of code, that's a 30% reduction in cost, and it also shrinks your timeline. So once I know what I have and use, do I understand what I have? So, in some cases, a lot of people do not understand what they have. So documentation is key to that. So you can do summary level documentation now, you can do detailed level documentation, which helps the developers now be able to rewrite applications much more efficiently. You can do sequencing diagrams, but that's on the, I'd say, the technical side. I'd say that one of the best advancements I've seen in the last year and a half is around being able to do it on the business side. So now I have a business model of how something works. So for example, in the credit card authorization space, my account management function uses customer data to, let's say, call a credit validation routine, which then makes a credit decision and passes that credit decision back. And if the credit decision is good, it passes it, to transaction processing. So again, it's in a business context. So now as your businesses are looking at, how what you have today is your business capability, they can redesign it. They can say, we don't use this capability anymore because maybe it's a life insurance product you don't use anymore, but you have a book of business you have to handle. So you've done acquisitions, you may have 3 of something. So again, understanding what you have really drives the next step of what you want to do. So how are customers accelerating their discovery? So I went over a couple examples, but I'm going to cover the ones I didn't cover, which is in green. So in the case of, technically I had one insurance company that had 2 Java developers and inherited 2 million lines of code, which is a lot of code. And they had no idea, they have no experience with legacy languages, and they needed to integrate with the third-party packaging they were moving to. So for them, documentation was key. They could use summary level documentation to kind of figure out at a high level what all the programs did. Then they could go down to the detailed documentation and extract those business rules so that they could then rewrite the capability. So again, accelerating that capability really makes it much more efficient for people to be able to rewrite code. So then you have to understand what works and doesn't work. So now I know what I have and use, and I understand what it's doing, what's not working. So uh, and to give you an example of this, I had a large insurer who had 40 million lines of code. A good portion of that code is a third-party product where they owned the code, but not the intellectual property. And over time, they had integrated in uh, uh, a number of complex actuarial computations that needed to pull out because they wanted to be able to pull out the stuff that they owned from an IP perspective and rewrite that into a new application and then work to migrate the other components to a third party application. So for them, being able to see that business model, they could pull out their business rules. So they needed to see a business view of it, not an application view. So they could understand what part of that were their calculations or their business capabilities, not the third party product, so that they can then extract that to create new capability. So some of the things that work and don't work that we see are, things like I may have my latency may not meet what a competitor does. My application may not be able to scale to meet the volume I foresee in my future. I may not be able to, I may have duplicates because I've done acquisitions. And now I have 5 systems doing the same thing through a set of acquisitions. So what works and doesn't work can be a variety of different things. But you can now do that analysis once you know what you have and really use. And I covered the top example already, but I'm going to go over a banking example. So I had a bank who met with us and they said, our code's crappy. These are their words. It's not meeting what we need to do. We can't meet the LSLAs we need to do. We just need to rewrite the whole thing. So then, in a workshop, we actually worked through them. And when we actually looked at it, because now we had some analysis, we could say, the problem wasn't so much the business rules. The business rules and functionality of the application were great. It was the architecture of the application. It made too many hops. So it made it slow to be able to process. So now they knew what they had to redesign was how it was architected, not the business capability. So again, these all tie to making you more efficient and making your modernization faster. So now that I know what I have to use, what works and doesn't work, I can now dispose my application. So I can go back to tie it back to one of those 8 patterns I talked about before. So when you dispose an application, application has multiple programs. So you may have different paths for each one of those. So you may have multiple dispositions on an application. And a lot of people, depending on your cost, your timeline, because for things like replatforming, refactoring, it is cheaper because it's an automated thing. Rewriting is more expensive, but the two are coming together with with generative AI advancements. And then a lot of people in this space, especially in generative AI, do bake-offs between tooling. Because again, of all the things I talked about so far, there's a lot of different use cases. You have to know what you're trying to accomplish, what's working and what not working, and what you have and where you want to go. So you can say, hey, my problem is I need to extract business rules, or my problem is I need to generate test cases, or my problem is I don't know what it does and I need the documentation to be able to see what I need to rewrite. So depending on your use case, people do bake-offs between tools because that way they can say, okay, here's the outcomes from looking at the same program across a couple tooling, and that'll help me make a business decision for where, what tooling I want to use to move forward. So I see that's more common with generative AI. And then once I know what pattern I want to do, and I've decided what patterns I want to pick from my application, then I have to transform. So there are multiple approaches to transforming with rewriting, especially with generative AI tooling. So people pick a few different approaches. So the one in the center, number 4, is some people want to create a whole new way of working, or they want to create a set of squads or a group of squads to do each component of the life cycle of a modernization. So they may create a squad that handles the discovery, and that underneath that you may have squads for one squad looks at the source code, one squad looks at the dynamic data, and then another squad ties all the maybe one squad has your business documents, and they tie it all together to give you your analysis. And then across the life cycle they create other sets of squads to handle other components of the life cycle. Or somebody may just say, I really want to understand the business more. So I want to extract the business roles or the business models because I need to understand what I'm doing from a business perspective. So that maybe I need a visualization of the model, like in the example I gave you with the account management. And maybe I try a set of tools across the function I know so I can see what works best. But then when I extract those business roles, I need to make sure I have tooling that can take that extraction of business roles, either export those business roles to me or be able to use them to make decisions. In one customer, they built their own business rules engine because in the way their business worked, their business team changed one business rule, it can impact like 5 to 10 programs. So they wanted to extract their business rules, put them in a business rules engine, and make those a human readable format that the business team could update. And as they updated a rule, it would get disseminated down to, let's say, those other 6 applications that use that same business rule. But in another case, the extraction of the business rules model could be used to check for duplication because it's a lot easier to see, hey, account management function, let's say, versus program AB 12345 and AC 12345 do the same thing because a program name doesn't mean a lot to the business. So being able to see that in that business view is really accelerating modernization. And the last one is reporting. So I've seen customers have 30 to 45% of their workload in reporting. So being able to accelerate that reporting, so as you make your data available, you may want to migrate your reporting off because again, data is the lowest risk pattern. Migrating your reporting off, with that data can also be a low risk pattern because don't necessarily have to change your applications or your core business capability. So people are looking at creative ways using generative AI tooling to go to, let's say, a natural language and then incorporating them through a set of APIs into a modern reporting platform. So there's a lot of different ways people are incorporating generative AI to speed up the transformation component. But to de-risk a project, customers are also looking at testing. 99% of mainframe, I'd say, companies have mainframes for modernization. They do not have regression test suites. And the reason that's being is because these applications are old and they're stable. So over time, as a new function is being built, they just add test cases around that function. They don't do an end-to-end regression test suite because they don't have to. But when you're doing modernization, you need that regression test suite. So having partner tools that allow the capability of creating your agile stories, grading your test strategy and your test cases is really critical because testing is 40 to 60% of our project. So I've seen, um, I'd say, uh, documentation from our partners that overall, just automating the test case creation and these test components, the agile stories, can shrink a whole project anywhere between 25 and 35%. So imagine that's your timeline and your cost. So again, it can decrease your cost, which improves your ROI. And the one thing not to forget about is that frying pan or the end-to-end observability, because now I have my applications together, my front-end applications in cloud and my back-end in cloud. I can now trace a transaction from front to end. So that allows me to have an automation to see if I have a performance slowdown or if I have an outage, I can pinpoint the problem. The old way of doing it, when some of the codes in cloud or on-prem and the other half was in the mainframe, they would have 300 people. I was on 2 of these calls myself. They had 300 people on the phone trying to figure out what the problem is. And then usually it was a subject matter expert in a domain that figured out what the problem is. Moving forward, you want to do that with automated capabilities. So being able to have that, not just the environment observability, but the application observability, so I can track a transaction to end is critical, especially if you have things like you're an insurance company and you're doing annual enrollment. You don't want to have a performance slowdown when, hundreds and thousands of people are registering, for their next year insurance. So again, end-to-end observability outside the application itself, but very critical. So I covered these 2 approaches, but I'm leaving here so you have it in the presentation. And then how do people get started? Like even before they getting started, how do people just start in general? So most of the times they meet with somebody like me or, a partner who does a similar thing. You have a discussion. You talk about what are your challenges and constraints. You talk about at a high level what the tech stack is, and you put in together maybe a hypothesis of what you want to do to get started. And that's where you go through how to get started on understanding what you have and use. So again, it is a complex, set of things, but it is doable, especially with generative AI, because that's really helped, cut down the components for like a rapid discovery, your discovery and planning, your testing. And so all those capabilities that you need in a whole life cycle of modernization has been, shortened due to generative AI. So I just wanted to thank you for your time today. If you have questions, please reach out to your AWS account team, or you can always feel free to reach out to me on LinkedIn.